Today we will be using systems thinking to explain the concept of positive feedback loops. On November 15, 2022, the world population surpassed 8 billion, so let's consider the positive feedback loops associated with population growth. To consider what a feedback is, we first must define the system by breaking it down into some essential elements. First is the stock. The element of the system you can see, count, or measure at a given time. We will call that P. In the population system, this is the number of people. When it comes to the global population, we can ignore immigration and migration as these do not affect the total number. The stock has inflows and outflows, which affect its number. In a population, this is births and deaths. This is obviously a simplified diagram of real life, but broadly speaking, a system is a set of elements that are interconnected and organized in a way that over time produces the system's behavior. The global population is a complex dynamic system that is constantly changing, so let us try and replicate some of that in our model. The changes in the global population can affect births and deaths, which in turn affect population. This creates feedback loops which can be negative or positive. Let us take a closer look. An excellent example of a positive feedback loop is the birth rate. In a population with a constant average fertility, as births increase, the population increases, so there are more people to reproduce, so births increase, and so on. You can see the reinforcing nature of positive feedback loops here. On the other hand, there is also a negative feedback loop. This is the death rate controlled by mortality. We can understand this by simply noting the deaths decrease the population. When there are less people, there are less deaths. As a positive feedback loop is self-enhancing and can occur whenever the stock can reinforce or reproduce itself, it can generate runaway growth. In contrast, negative feedback loops often regulate growth as they oppose the direction of change imposed on the system, returning it to a stable state. If the positive and negative feedback loops are equal, then the population is in dynamic equilibrium. However, we know the population is continuing to increase, so clearly, that is not the case. This is because the population is a complex adaptive system, meaning there is a fusion of biological and non-living things. This allows the system to learn over time. In this example, I'll call it innovation. We can add innovation to our system's diagram. The more people there are, the more opportunity for new ideas and innovation, called complex adaptation. This allows the invention of machines to manage the land better, modern medicine, and public health techniques. These reduce the number of deaths. As the death rates are reduced, there are more people, and more people allow for more innovation, creating a positive feedback loop, which we can see here. When we consider this with the model of the whole system, we can start to see how different feedbacks interact. The positive feedback loop created by innovation dampens the negative feedback we previously mentioned associated with deaths. In comparison, the positive feedback becomes more pronounced. The reinforcing nature of positive feedback loops causes the exponential growth we have seen within the population system. This can cause the system to spiral further away from equilibrium and towards an overshoot. What does that mean, you might wonder? The Earth has limits to growth in the form of finite resources such as water, land, and fossil fuels. In systems thinking, a finite resource has no inflows. Therefore, it cannot be replenished when it is depleted. Infinite growth on a finite planet is growth that cannot be sustained and could result in catastrophic consequences for the population, such as famine and water insecurity. Regarding limits to growth, we can see as the population increases, resources decrease. This is why exponential population growth can be considered a sustainability challenge. To recap, a positive feedback loop is one that is self-enhancing and can reinforce itself. We have explored positive feedback in the context of the population system. By applying systems thinking, we can break down and visualize the interacting feedbacks and explore how positive feedback loops can form. The threats of feedback loops that reinforce themselves and move the system away from equilibrium have been considered in the context of limits to growth. Ultimately, the finite nature of the Earth and its resources coupled with exponential growth caused by positive feedbacks is a contemporary